Okay, so we're talking histograms. Now, last lesson we were talking about continuous data and discrete data. So can you remind me about the difference? Right?
Continuous data has an infinite number of values, so therefore it's like measurements.
Yeah.
And discrete data is categorical, so therefore it's counted like, i.e. the number of cars.
Yeah. Yeah, she is, yeah. Yeah, so, and we can display this information using different types of charts. And the charts we're going to look at today are histograms. Now, you may think actually we're just doing bar charts. So there is a link, and sometimes bar charts are just called histograms. But there is a difference. Okay? Now, just to go through, what would you say about bar charts?
They're easy to read.
Well, if we were to sketch a potential bar chart, what would you expect a bar chart to look?
It has bars.
It has bars. Axes. What would this axis be?
North.
Would it?
The frequency axis.
You're talking scatter plots there. This would normally be frequency, wouldn't it?
And then on the bottom, quantity.
And this would be,
Maybe time.
well, it could be anything, couldn't it?
Yeah.
Normally, if it was a time series graph, meaning the x-axis would be time, that would actually be a line chart to show how things change over time. But with a bar chart, for instance, let's go about, let's do one on travel options. Travel. So, I could do bike,
Bus.
bus,
Car. Caravan.
car.
Train.
How many people get a train to school in Bermuda?
Me.
Caravan.
They used to.
Okay, so my bar chart
Where would you land then? On the roof?
would look something like this.
Question. Do they have to be separated apart?
Well, that's the question, isn't it? Why? Why have I separated?
Because it's not compared.
What type of data do we have?
Oh, categorical.
Okay, so we've got categorical, which is also beginning with D.
Discrete.
Discrete. Now, as I said before, does it matter in what order those labels are put? Could I put walk first?
It don't know.
It doesn't matter at all. So we have categorical and discrete data. Therefore, we have just a bar chart with the gaps, and the gaps show me that those things, they are discrete groups. Sorry, let me know when you're done.
Actually, on that, I have a question. Is there such thing as indiscrete?
No, it's continuous. Okay. Ask me then.
That's what it came.
Alright, so we have gaps because we have discrete, they are separated categories. They could be put in any order, and what we're looking at, the bar chart basically just tells us how, what's the most frequent. Okay. Now let me just ask you a question. Could I state a mode of this data?
No way.
No?
Yes, you could.
Okay.
Walking.
The mode would be walk. Yeah? The most common character.
Exactly.
Yeah? Could I state a mean?
Yes.
You don't have any value.
You can't.
So no, I can't if I need to know the values.
I don't.
What can I add together?
The bike, the bus, the car, and the
How do you add bike and bus?
No, but you can
add the
show
The frequency. You have to.
So in other words, you can't. Yeah. You couldn't. There's no point writing bike, add bus, add car, add. You know, because they're not that. You can only work out. Hope you're not going to do this tomorrow. You can only add up values that can be added. So with data like this, you can't work out a mean. In the same way, then, we can't do a median because there is no middle value, especially when you can put them in any order you like. Yeah, I can't do them smallest to. It's not like walking is smaller than bike, which is smaller than car. You know, that doesn't make any difference. So I can't do mode, median. I can do a mode. I can't do a mean or a median.
What about a range? Can't do a range either.
No.
Could I not do a range?
Yes, you could.
How?
Yes, you can. From the lowest to the highest.
Walk
So the
minus
bike-
But you don't have any
Oh
numbers.
no, never mind. You can't because you have to subtract the two. Just do.
Just
Okay. So this is when we've got gaps in our bar chart.
yeah, but actually, if you subtract a walk from a bike, you got a car.
Yeah.
Because look, it's 1, 2, 3, 1, 2, 3.
No, Malay.
Well, there's a question. If it was, let's say it was 3, and this would be 4, 5, 6, 7. Okay. Something for you to have a look at. Maybe you can use your textbook. Would the range be 7 minus 3 to make 4?
Yes.
Yes.
No, because you're not. That's the data. Oh.
No.
Well,
But she just gave it to us.
let's have a think about the CD sales. The range for the CD sales was what?
6.
Because it was what?
Largest. 8.
Okay.
Well, we don't have
So the largest was what?
7.
Did I?
Walking.
Wait, 8.
It was 10, see?
So the range.
It was 8.
So this was the number of CDs sold.
It was yes.
Okay. But this one that we're looking at now is the number of people. Does it make the same sense to say
No.
It's different things.
it's a different content? Just maybe say.
Wait.
Go on.
Never mind.
Because I was actually, do you know what? I was quite impressed when you told me, all of you immediately said the mode was 5. So tell you what, there's comments below where the people that made this website, they said in their answers, okay, that the mode in this case would be Monday and Saturday.
Where?
8. Yeah, because 8.
Because it's the ones that have the most in it.
I thought most.
But someone commented and went, that doesn't make any sense. Okay? Because the mode is what occurs the most often. And what occurs the most often in this context is,
Thursday and Friday.
well,
5.
5 sales occurs the most often. Right? Well, you guys went straight for that. You didn't make the mistake that the guys making the website made. So I thought you might say, well, yeah, I thought you'd say Monday and Saturday, by mode. Now in this case then, something to think about, is the mode walk? Because we've got a different situation here.
Oh wait.
Yes, it
It's
is.
a different bar chart because we have frequency data. So the modal
There's
form
no
of
mode,
transport is
Walk.
walk. The range of that data, well, I'll leave you to have a look in your textbook in a bit, see whether you can decide it for yourself. Right, let's have a look though at a different type of bar chart, another frequency chart we'll call it. Right, so we've still got frequency. Give me something that would be continuous data.
Colors.
Height. Colours?
Numbers.
Height. So, height of
A building.
People.
Students.
Lights. Trees.
Tell you what, the reason why I'm not going to go for the height of
Trees.
people in class is because there's not much variation. Buildings, okay. We'll go for buildings just because there's lots. Or trees could be. Let's think. So the reason is when we do our data, we group them. Yeah. So we are looking at grouped frequency. So we're saying we're no longer interested in the individual data, because with continuous data, depending on how accurate you measure it to, you might have lots of different individual numbers, and then the frequency of all of those numbers might be 1, and you'd have lots of 1 high bars, which is no point. So we group it so that we are having stuff that's more interesting. Now, this grouped frequency, what kind of groups would we have for the heights of buildings? So I'm going to put H. What could be the lowest height we would consider?
10 feet.
5.
Of course, you're in feet and inches, aren't you? So you're all used to walking into 6-foot high buildings, are you?
Yes.
Really?
50 foot.
Mr. Nightingale's going to struggle with that one, isn't he?
He's not coming.
10 feet.
Even you? Are you lot going to go
20 meters.
upstairs in a
20 meters.
6-foot high building?
Yeah.
It's like that tall, even on me?
If it's 50 foot tall, you're all good, right?
1,000.
So what do we think the lowest height? 10 foot. Okay, let's go 10 to...
10 to
Should we just now? 10 to 15,
15 to 20.
15 to 20,
20 to
20 to 25.
You should
25
switch it to meters.
30.
We could, but you started in feet.
30 to
I prefer meters. Right, let's just stop there. So our heights, if I was going to be doing these, do you remember what they're called? Sure, I gave you another way of saying it last time. Class intervals. So these are my class intervals.
Where do we see that? Where's that?
And how would I use my inequality signs?
You have to use greater than 10
Okay.
And equal to.
Less than or equal to.
Right, which one would I put, and does it matter, my and
You
equal
put
to?
the lowest one.
Oh, yes, it does
It
matter.
does. It's the first
Put the
one,
lowest
but it has to be less greater than or equal to.
Because if we had a 10-foot high building, we'd need to be able to put it. Now, you might not necessarily always see that, right? So if I know, and this is where knowing your maximum and minimum data pieces is potentially important. So how would I label my x-axis of height then?
Well, sir, so you can go up in 10.
Okay, now I'm going to put a little squiggle thing there. Have you seen that before?
Yeah.
Yeah. So that means I don't need to start at 0, so I can start at 10,
15.
15,
20. 21.
You sound like a race car.
Okay.
That was my dog.
Now, here's the thing. The difference between discrete data and continuous is because there's no gaps in the groups, there's no gaps in my bar chart, in my frequency diagram. So, for instance, I might put a bar like that. Okay. The next bar, next bar, and then there's no gaps. Now I've just made up numbers there, but I've kind of done it because I'm thinking there's quite a few normal houses, and then they drop off as they get a bit taller, but then they go to skyscraper type ones, so they get there's a lot of them again, so it tends to be small or lots of small, lots of very large. So that's how I would describe my distribution. So that would be a bar chart for my continuous data. So you notice there's no gaps, and that's the main thing. you notice how my intervals are at either end of the bars. Now we could change that and write in the middle, okay, I could write it as 10 to 15, but that's what that means, having the bar between 10 to 15. Now that's different to how I did here, where bike was in the middle of the bar. Yeah? Bus was in the middle of the bar, and so on. Okay. So I show that. That's why I keep repeating it. There's no gaps between. So you should write that. So continuous data, no gaps. Right, we have no gaps between the bars. Right. So that's where they're just basically frequency diagrams. So this, I would say, if I had my table and I put my frequency table there, this would be called a frequency table, right? And then I would have my frequency diagram, my frequency chart. Now, if you look at the first page of your past paper questions, what do you notice about the y-axis?
It's some discrete. It says frequency density.
It says frequency density and not frequency. So for me, this is where bar charts and frequency charts turn into histograms. But just to let you know, that's not what everyone seems to use. So for a lot of people, bar charts go horizontally. I don't know if you've seen in Excel when you've done them, bar charts tend to go horizontally and histograms go vertically. But for me, histograms are not frequency, they're frequency density, which we have to deal with them in a different way. Right? So let's have a look at that question. Right? So if you've got that first page open. Now, to explain why we have frequency density and not frequency, let's have a look at the table, right, that we've been given. So I've got my frequency table. So, could you, first of all, could you interpret that table for me? What is so the first thing you should always do is, before you start drawing charts and things, interpret the information they give you. What is this about?
It's a graph of what time people completed their run.
Okay, one thing that always comes up in a question like this. Which end of the table is faster runners?
The 30.
Okay. It's amazing how many people go for the end. It means bigger and better and faster, and you know. But actually, these are the fastest people. Yeah. How many people took between 12 and 35?
12.
From 30 and 35. 12. Sorry. 12 people.
Not if you ran.
Now, what do you notice about the group, the class intervals that I haven't done with the previous teachers, or the previous one? What do you notice? Look at the class intervals.
62.
What are the class intervals, and what do you notice?
They vary. Because it's from 30 to 35, 35 to 40, and then 40 to 50.
So 35 to 40, so that as a class interval of 5. But then we change it to a class interval of 10. Now what, and actually, sorry, I've gone one further. I actually should have a third colour, and this one is, why do you think they've done that? Why have they chosen their groups to be different sizes?
To confuse us.
No, not to confuse them.
Because they might
Definitely not to confuse them. Pardon?
They might not have data.
Not that they don't have data, because you can see that there is data, but what tends to happen when you're in a running race and you're being...
There's different groups.
Some people don't have
groups that's really
good.
fast.
Okay, so you tend to have, if I think about it, if I'm running a race and you know, I tend to have a group near the front, you know, and they're relatively closely packed, quite a lot of people, yeah? Not necessarily talking about school sports days, because that ranges massively, but if I was in a big, like the Bermuda National Championships or something, I'd have a big group of people all not separated by very many. So I would want to be able to separate them and show more accurately where they are placed. So how many people got in the first second, the second second, the third, and so on. Does that make sense? So there's a lot of people. But after I go a bit further down the time scale, there's less and less people till you get to the few people that are just off the pack, and then there's the one person right at the back. Yeah. So the number of people gets less and less and less. So it makes it less important for me to have separate groups, because I might, for instance, if I kept it as every 5 seconds, I might actually have lots of groups with no one in them. Yeah? Because it might be lots of people 30 to 35, lots of people, but then this people might be a reasonable spread, but here at the 60 to 80, they might have all got 75 to 80 for all I know. Right? They might be the people that normally, I don't know, they're normally not interested in sport or whatever and do so they're all grouped at the end. But then I would have nothing in the 60 to 65, 65 to 70, 75, 70 to 75. I have no one. So I might as well group them all together. Does that make sense? So that's why the class intervals change. I'm just looking at what I want to see. But the thing about that is, that affects how my frequency chart will look. If I'm going to group things together, that would put the bar higher, wouldn't it? Because there'd be more people in that group. But the group's bigger, so it's not really a fair display. And that's where frequency density comes in. Right? So, let's have a look at these questions. So it says, use the histogram to complete the number of runners who took between 40 and 50. Now, we are not told how many people in total, so we can't do it that way. So we've got to use the histogram, and we've got this information for 40 to 50. Okay, we've also got this information for 50 to 60. So if I look at 50 to 60, I know there's 12 people. So if I were to label this histogram now, what do you think you would do? How could I use that? So would you put here,
You would find out how.
put that as 12?
Yeah, and you'd find out how much 12 was, and then.
Right, well, that's the big mistake. Because that would make that axis the what axis?
Frequency.
The frequency axis. But it's not the frequency axis, it's the frequency density. Right? So the way a histogram changes is this no longer is frequency, it's frequency density, and the area of the bar is now the frequency. Because obviously the wider the bar, it doesn't go up as high even with more people. Does that make sense? So the heights are still representative. So for a histogram, the area of the bar equals the frequency. So I know that the area has got to be 12. So the class interval I know is 10. So 10 times what makes 12? Not quite.
6.
Oh, my bad. 0.1.
No, 1.2.
1.2. So actually, this mark here for the top of the bar, this mark is actually 1.2. Okay? Because what we're saying is the height of the bar multiplied by the width of the bar has to equal 12. Alright? Alright? Make sense? So now we can use that information in the same way that you would have used the frequency to work out everything else. So what do you think? So now we've got to count squares and distribute it between 1.2. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares, and that's got to equal 1.2. So what was each square going to be worth? 0.2?
It's 15 squares, I think.
Is it 15?
I could be completely.
No, it might be. 1, 2,
Yeah, it
I
is.
counted
It is.
4, 5, 6, 7, 8, 9, 10. You're right. I'm wrong.
I will find out.
So what do we do? We just do 1.2
Divide 15.
divided by 15.
0.08.
0.08. Okay?
Square equals 0.
Alright. So each square is 0.08. So to then work out this, it's not a very nice question, this one at all, is it? Because this one is, we'll have to assume it's half a square. So how many squares have we got? 10, 20, 30,
So it's wait.
so 37 and a half squares. So that's
3.4.
times 0.08. What is it?
3.4.
3.4?
I don't think
3? Exactly 3.
Yeah, that's what it says. But if you say.
Alright.
so. Then you do 3 times 10.
So yes, exactly. So now the area of this bar is its fixed. So now we've worked out the height is 3.
How could that be just 3 if it's halfway between? Like,
Because remember, each square is 0.08. We did 37 and a half times 0.08.
30?
Well, this is only 1.2, so it's not going to be much more anyway, is it? It's definitely not going to be like 28 or something. So we've now got 3 times 10 makes 30. So we
Oh,
think
that's your answer.
that's our answer. So there are 30.
That was a lot for 2 questions.
Yeah. Too much.
Wait, why didn't it have second?
Because 40 to 50.
It's the class interval at the bottom.
Alright, got it.
Okay. Alright. Is there anything we need to add to these notes that you're going to write on this? Because these are your notes for this on this question. So is there anything you want to add?
So between.
Okay. So then the next question is finish it, yeah? Complete the histogram. So for each one we've got to work out what its height would be. So for instance, I'm just going to use this space. So what's the class interval? So we need 5 times what equals 12. And then for the next one, we've got 5 times what equals 20. These two are done, so we've then got, this is where they're checking your reading, it's going to be 20 times what equals 16.
Ah.
So it's 24.
So, first one,
2.4.
12 over 5, you think is 2.4?
It is 2.4.
Okay. 20 divided by 5 is 4. And then 16 over 20 is?
Error.
1.85.
1.8? No?
2.5.
But 1.25.
1.25.
1.25.
Can you just add 12 and 20 together?
Add the 12 and the 20.
Is that okay?
What?
Yeah,
What?
from 30 to 40, which is what is on the axis. What? In the histogram, it says 30 to 40.
Completely
Could you just add these two together?
Flabbergasted. No. You have to do it separately like it says.
Well, yeah, I mean, I'd be reading this, I don't know in the answers, but I would be going, I need separate bars. So what do we have? 2.4 first, so we need to figure out where that would be.
1.6, I found it.
What do you think you are?
What would it be? 2.4, so double that. So that would be here, yeah? So that would only be there.
2.4.
So that would be that first bar.
What did I get?
We have a national game.
Should have sorted that.
My guys over here.
Should have sorted that, shouldn't I?
Can I get it?
Well, you know the consequences, yeah? Okay, so the first one, the next bar is, what did we say it went up to?
Wait, what's this black line thing?
The 50 to 61. Isn't that the same as the 30 to 35?
Can't we just do it?
No, it's divided by just number.
So, are you all seeing what I'm doing?
Yeah, I am.
So I've worked out the question, they are the positions on the y-axis, this is my frequency densities. So the first one's this one, for 30 to 35, has a frequency density of 2.4. So I've gone up to 2.4 on that one, okay? The next one is going to be 4, yeah? So, where is that on the axis? So where is 4 going to be? So how many squares is it going to be?
Well,
So was it 4 divided by 0.08?
ow.
So how many little
50.
squares? What?
50.
50. Okay, that's nice and easy. So I've got 10, 20, 30, 40, 50. So that mark will be the 4. So my next group, the 35 to 40 group,
Oh god, I forgot it was split.
yeah, be careful, will be that bar. Okay?
Trying hard.
Why are you
Yeah.
putting it in the middle?
Because it has.
Because the groups, it
Oh, 0.5.
it was split to 35, wasn't it? Yeah. And the final group covers 20, so the 60 was at 1.25. So I've got 1.2. So the next square, where's 1.25? How many squares? Well, remember each square is 0.08.
So times.
So do 1.25 divided by 0.08 again. 15.625. So we reckon it's 15.625 squares. So we've got 10, 15.6. So I'm just going to it's going to be a bit of an estimate. 15.6. I'm just going to put it just above.
0.25.
So it's going to be an estimated. So that's what it's going to look like.
Oh, fat one.
What are you doing?
So just to make it clear for you, you're not going to be expected to do this in your exam at all.
Okay, good.
But I'm just going to colour it in just so it's clear to see.
Oh, I think with this question.
Me too. I was like, oh, great.
Oh no, you might have to do.
I have to color it anyways.
Wait, how? I thought the next.
Save it till the end of the exam if you've got nothing else to do.
I thought the
Right.
Just remains. During the remains of stuff.
Now, girls. So just to say, this is then the impact of doing frequency density rather than frequency, in that this group has 16 people in it, alright, which is more than the 12 in this group. So this group here has more than that one and that one. Now it is slightly higher than this one, but it is well below the 12 in this group. Now that's where the frequency density comes in, because I can now see, well, this 12 is more impactful, shall we say, than these 16. The reason for that is those 16 are actually spread across a larger range of times. These 12 are all combined in a much smaller time, so they should have a bigger impact on how I analyse my data, what it looks like. So that's why I want the bar to be higher. If I just did a normal frequency one, this bar would be higher than both of these. All right. In the same way, this is 30, right? But this one is only 20. But because it's half the size of the group, the bar is much higher. Okay? So do you understand the difference between a normal bar chart and, in my case, a histogram in this way? Yeah?
Sure.
What you need to be very aware of then.
Is this how a histogram would look?
You need to make sure that when you see these charts, you look at the axes and you check what it says. If it says frequency, it's one thing. If it says frequency density, you'll know you're doing a whole different type of calculation. All right.
That's okay.
Now, they quite often stick a question like this in. Now, I had the comment there that there's not that many marks available for that kind of work.
And it takes a long time.
Me too.
Now, that is potentially because lots of people lose marks on questions like this.
And they try to
Therefore, they're trying to lessen the impact of it,
Yeah,
because it's like,
How nice is that? But if it's like 1 minute per mark, that's hard to do that over.
yeah. I mean, it's not hard maths. It's not hard maths, especially because you're going to be doing it on your calculator. All right? There's less knowledge. If you think, do you remember, tomorrow we're going to be talking about a question and how much knowledge you need. For a question like this, there's a lot of doing, but there's not a lot of knowledge that you need. You just need to remember, area is frequency, and that's it. Right, this is one thing I wanted to go through then. So it said, calculate an estimate of the number of runners awarded silver medals. It says, runners achieved a time between 37 and 48 to complete the race were each one. So between 37 and 48.
That's cool.
So let's mark 37 is there, and 48 is there.
Are we sure?
So we are looking between these two values. Come on, change.
between 37 and 40.
So between this and this, that's where the silver medals are awarded. So what would be your estimate?
Can't only one person get the silver?
Well,
30.
No, because it's saying everyone that got
45.
runners who achieved complete the race were each awarded a silver medal, rather than a silver meaning second. It's more like an achievement medal, let's say. So how would you go about doing that?
46.
So again, it's just so it's between a. Well, what would be your reasoning?
Can we go up?
Because 35, right? I'm just thinking 35 to 37 is 2, and then 45 to 48 I lied, so therefore it's 45.
45.
It's 3, and it's 6.
Now again, frequency is area, right?
It's 36. Don't you just do like 2 times 4 to get the number of people who did it, because that's the area, and then you add the new area of 8.
So sorry, 2 times or
3 times.
so this one would be 3 times 4, because that's my frequency density of the green one. So that would be an estimate of 12, and then this one would be
8 times 3.
8 times 3 makes 24, so that makes
36.
now just the question, why has it said calculate an estimate?
Because it's a rough.
Because you don't know. You don't know where they actually are. They might have all been in the 35 to 37 bracket, and therefore no one in there, but we assume it's nice and easily, evenly spread out. So again, it's just a kind of point of note, it's an estimate because of you don't really need to change what you're doing.
Being you said that, let's say we get this in a test or whatever, can we argue that, no, we have to do that?
They're expecting you to look at the fact that
This would be the new area.
that's the proportion of the shape. Now you might, I don't know, check the mark scheme at the back. Is that how they might offer you a range depending on?
36. It's 36.
Do they give you a method for it? Do they offer you any kind of
There's no range.
no range? Does it give you any notes on the right hand
It says 3
side?
times 4, 8 times 3.
Yeah. So that's what they're looking for, and they're not going to offer you any kind of.
36 is the answer.
I'm just looking. Have a look. Doesn't give you the answer. All right. How do you feel about that?
I don't know, you know?
All right. So next question. I'm not going to deal with it straight away. But remember what I've said. The table gives information about the areas of some farms in France. Look what it's got on the axes. Frequency density. So we look at it and say 0 to 20, 20 to 50, 50 to 100, 100 to 300. Right, so you've got several different group sizes there.
So from 37.
Okay, so I'll leave you to have a go at this.